the mouse and sort of take this stylus. And what I've got here is, and I'll show it to you two configurations, is a prototype of what I think a more futuristic desktop environment will be. But I think it's one where touch and many types of displays will become more commonplace. In fact, my personal prediction is that the successor to the desktop computer will be the room. And you'll sort of be in the computer. You'll have display surfaces around you and in front of you, and that these things will all come together to support telepresence and a lot more visualization capability than even we have today on the traditional displays. So here, this tablet's one that's high resolution so I can write on it. So the next demo, I'm going to think that I'm basically an energy-related researcher, and I'm trying to study different zero-carbon sources. So I just want to sort of do a search, so I'm going to start writing zero carbon here. And I think much as happens today when you start to fill out an email address, it knows kind of who you've been writing to, and it gives you these suggestions. Increasingly, the computer will become more proactive and less reactive. Today, it's just a great tool, and it's evolved from a very simple tool to one that's incredibly sophisticated, but it's still a tool. And in fact, if you look at most people's computers today, they're idle most of the time because they only wait for you to do something and then they react. I think that will change a lot. Computers, will increasingly try to anticipate what might be of interest to you and anticipate what you're trying to do and help you complete those tasks. So here I might just use another gesture like circling it to say that's okay, and maybe write a picture of a magnifying glass to say go do a search on this. So here I might go out and bring back, say, 5,000 documents that are many different forms of things that relate to this. And of course, at that level of resolution, it's not very useful. But I think the other thing that increasingly is happening is we have more and more metadata. And the ability for the computer to analyze this metadata at a scale that would be impossible for me to do it gives it the potential to help me more. So I might say, computer, organize it for me. So here it can sort it and cluster it into different groupings based on research or colleagues that I work with, news stories, and allows me to essentially start to drill in on the things that are more interesting. Like the computer, zoom into research. So now I'm getting a little higher granularity activity. And in this workstation, we have cameras that actually track me and my position, but they can also start to do eye tracking. So I can sort of just look around, and it'll pop up individual documents, and I can stop on one. Happily, this one is the University of Washington. It's amazing how that happens. And so, in this environment, I can now use the pen and click in. I might, be tracking stuff that's going on here and related to energy research. And, but I also track a lot of other things. So I might use my pen or vision to essentially scan around here again. But I know that here's a blog. In this case, it's one we made up, but it relates to ones that actually are out there called Zero Carbon News. And so I go here to see what people think is interesting and happening these days. And so I want to look at this nuclear research review. And here there's a story about traveling wave reactors. Now, it turns out this story is actually a real one. There's a company here in Seattle, or Bellevue, called TerraPower. It was funded and started by Bill Gates and Nathan Myhrvold in a private capacity. And I'm friends with many of the people that are involved. And here, to me, is a very interesting story. And if we look at it, Edward Teller and some people at the who worked on the original Manhattan Project and built bombs, in late life when he was at Lawrence Livermore, came up with the idea that there were other ways to build nuclear reactors, and they would not exhibit most of the problems that we have with nuclear power today. But no one really had the capacity to pursue them at that time. But Nathan and Bill and this man John Gilliland and some others realized that in that intervening time, since the early 90s, computing had gotten so powerful and so inexpensive in relative terms that you didn't have to be the weapons lab to think about these things anymore. You could do it in your basement, so to speak. So they actually hired a bunch of people and decided to embark on an exploration of this other alternative form of nuclear power. And I think the work is at a personal level, I find it very exciting and quite promising. And it would certainly be a silver bullet for the society if it could be built. So here I might know that John, in fact, has published a video clip that talks about it. So I might just make a play sign here and listen.
We believe we've developed a new type of nuclear reactor that can represent a nearly infinite supply of low-cost energy, carbon-free energy for the world. One can visualize our reactor by assuming there is a cylinder, for example, 60 centimeters long. A small amount of enriched uranium is used to launch a wave. After that, the reactor makes and consumes its own fuel without the need of refueling or removing waste from the reactor for the entire life of the reactor.
So I find this a pretty interesting concept. One, it turns out that what it uses primarily for fuel is the waste that comes out of today's nuclear power plants and all the stuff that goes into building their fuel assemblies. And today's nuclear reactors only get low single-digit percentages of the energy out of the fuel, which is why we have such a great amount of highly radioactive waste. These things can get about 90+% of the energy out of the fuel, and they burn, sort of, as he says, in one pass for about 60 years. So it's sort of a use once and discard, and so it becomes its own burial cask for the little bit of radioactive waste that remains. And so the waste that we have in this country today, if you could power the whole country with just these kind of reactors, would provide zero carbon energy for everything the U.S. wants to do for several thousand years. And so, this is an example of what I talked about earlier, where I said, look, I think the science and engineering community, they will step up and offer the society alternative ways to solve these problems. But to do this obviously requires many people to get involved and think about how that would work. So let's think of this as a place indeed where we were examining and looking at this published research, and I want to take it and sort of build on it. So I got this idea I showed you a minute ago of the science studio or sort of a science workbench, and here I might just actually take the diagram as a proxy for all of the metadata underneath this and drag it and drop it into my science studio. So now what I've done is I've taken the model and all of the data related to the model, and I've loaded it up into my own workbench. And so now I can try to understand this thing better, or maybe I can offer them some suggestions. So here the model has a variety of parameters that are tracked, power, flux, burn up of the fuel. And if I want to understand how does this work over a particular period of time, I might start the simulation. I'll say, okay, I want to run from 0 to 45 years. And go ahead and do the simulation. Let me see how it propagates in there and what happens at the end. So here the model actually keeps track of these various parameters and indicates on the right that 3 out of 4 were sort of within the objectives we had, but flux was not. So I can look at that and say, all right, a little below where we wanted. I wonder if there's a different geometry. Now in this case, while these have all been simplified for the purpose of this demonstration, these are actual models that John was good enough to give my group in order to show what it might be like to work on these kind of problems. So here, if I think of, just as they did, about having a lot more computer power available, how can I get that computer power to be even more proactive, if you will, in helping me search for solutions in a space where really nobody has ever done it before and there's no intuitions. And of course, that's what modeling and simulation are all about, particularly when you're trying to figure out how well it works over a future 60-year period. You can't wait around and build one and try it, because it takes 60 years to burn through. And so simulation is really the only way. So here I might actually take some of these parameters and say I want to have the computer, a lot of computers, do an investigation of different reactor geometries. So the computer, run a parameter sweep across 5 reactor geometries. So here it might go to a library or just randomly generate some variations on the different geometries, load up the different parameters and materials, properties, and start to compute how the burn